Welcome to Unit 5, Lesson 3, Derivatives of Inverse Functions. What does the word inverse mean anyway? Inverse, you can think opposite or reverse. For example, uh, 3, if we let's say 3 plus 5 and then minus 5, well, gets us back to 3. So 3 plus any number minus any number is minus the same number must be 3. If we do addition and then we subtract the same number, we get what we started with. So addition and subtraction are inverse operations. Similarly, multiplication and division are inverse because if we take a number times 3 and then divide by 3, we get the same number. Exponents and radicals, like square roots, are also inverse. So for example, 2 to the third power, and then we take the third root, it gives us back 2. So exponent, the third power, that's the exponent, and the root, the radical, are inverse operations. What I wrote here just means that 5 to the a power, you take the 8th root of that, gives us back 5. So that's what inverse operations are. Functions can also be inverse. For example, let's say that f of x is 2x plus 6. Well, if that's the case, then f of 3, well, that's to f of 5. F of 5 would equal to 2 times 5 plus 6. 10 plus 6 is 16, right? So f of 5 is 16. In other words, the function f of x takes us from x equals 5 to y equals 16. I'm going to use y equals f of x. In math, we like to say f of x maps x to y. Okay? So it takes us from x equals 5 to y equals 16. Now, we let y equals f of x, so y equals 2x plus 6, our function. Let's flip it. I'm going to flip, because inverse means reverse or opposite, right? So I'm going to flip the x and the y. I'm going to put the x where the y is and the y where the x is. So y equals 2x plus 6 becomes x equals 2y plus 6. Let's solve for y. So I'm going to subtract 6 from each side. So I get x minus 6 equals 2y. Then I'm going to divide by 2. Or I can multiply by 0.5, same thing. So I get 1/2 of x minus 6 equals y. Okay. So these are opposite. Okay. So all I did was I flipped x and y, and I figured out what y is. What we can say from this is that if f of x is equal to 2x plus 6, and we got that right here, that's what we started with. Then we can say that g of x, which equals to 1/2 of x minus 6, or 0.5 times x minus 6, same thing. Okay. We say that f of x and g of x, they are inverse. They are inverse. Because f of x and g of x are inverse, the way we write it is we can say g of x is f negative 1x. This is not exponent. This just means inverse. Okay, the negative 1 here means inverse. Okay, so that's inverse functions. Example, f of x equals 4x minus 3. We want to find the derivative of the inverse of x, f to the negative 1x. Okay, first, let's find f to the negative 1x. Find the inverse. Remember to find the inverse? I'm going to start with y equals 4x minus 3. Flip. When I flip it, I get x equals 4y minus 3. Now I solve for y, plus 3 on each side. Divide both sides by 4. 1 divided by 4 is 0.25. So y is 0.25 times x plus 3. In other words, f, the inverse of f of x, is 0.25 times x plus 3. Which, is also equal to 0.25x plus 0.75 if we distribute. Now we want to find the derivative of f of the inverse. So the derivative, okay, I can write it in this notation. That means derivative. Derivative of the inverse would have to be 0.25. That's it. Because the derivative of 0.25x plus 0.75 is 0.25. Yeah. More about inverse functions. So we saw that 4x minus 3 and 0.25 times x plus 3 are inverse. What we know is that if they're inverse, remember inverse operations, if we add and then we subtract, we get the same thing. Well, if we take one function and then we apply and then we plug that into the second function, we get x out. In other words, f of g of x is equal to x as long as f and g are inverse. Here's an example. So from the last problem, we saw that if f of x is 4x minus 3, then g of x, which is the inverse of f of x, is equal to 0.25 times x plus 3. Then what is f of g of x? Okay, f of g of x, I'm going to type this one more time. Well, what is g of x? G of x is this thing, 0.25 times x plus 3. So I'm going to replace g of x with 0.25 times x plus 3. Therefore, f of g of x is just f of 0.25 times x plus 3. Well, what is f again? F is 4x minus 3, right? So we have 4x minus 3, except it's not x anymore. X is replied by everything inside here. F replaced by everything inside here. So f of g of x is 4 times everything inside. That's 0.25 times x plus 3, and then minus 3. Let's simplify. 4 times 0.25 is 1. And then we have x plus 3 minus 3, which is x plus 3 minus 3, which equals x. So we saw that f of g of x equals x. We take the function g and then find the result to plug it back into the function f, and we get out x. Why? Because once again, the function f takes us from x to y, and the function g takes us from y back to x. So if we apply one of them and apply the other one, we get back our original, which is x. Okay. Next, this is calculus. So we're going to talk about the derivatives of inverse functions. Let's say that f and g are inverse functions. What is the derivative of f of x, f prime of x? Well, we saw that from the last slide that if f and g are inverse, then g of f of x equals x. So let me write this out. So g of f of x equals x. I want you to take the derivative of both sides. Derivative with respect to x. So I write d over dx on both sides. Okay. The right hand side is easier. Let's do that first. The right hand side, we have the derivative of x with respect to x. Well, that's just 1 by the power rule. The derivative of x is 1. On the left hand side, we have the derivative with respect to x, d over dx, of g of f of x. Well, that's just the chain rule. Remember the chain rule says df over dx. I'm not going to use f here. Let's use a different variable. The chain rule says dg over dx is dg over du times du over dx. Another way to write the same thing, dg over dx is the derivative. Well, u is f of x, so it's the g prime of f of x times f prime of x. Okay. In other words, d of dx of g of f of x has to equal g prime of f of x times f prime of x equals to 1. 1 we got from the right hand side. Okay. We're almost there. Our question says find f prime of x, so that's why f prime of x divide both sides by g prime of f of x. So f prime of x is equal to 1 over g prime of f of x. Okay. In other words, if f and g are inverse, then the derivative of f is 1 over the derivative of g of f. Alright, let's use this to help us solve problems. We'll look at 2 examples. Okay. Example 1. f of x is 3x squared plus 6x plus 12. Okay, A, find f of 4. Okay, let's just do that. F of 4 has to equal 3 times 4 squared plus 6 times 4 plus 12, which is 3 times 16 plus 24 plus 12, 48 plus 24 plus 12. 48 plus 12 is 60, plus 24 is 84. So f of 4 equals 84. Part B. Well, g of x and f of x are inverses. So g of x is f to the negative 1 of x. Find g prime of 84. Find the derivative of g at x equals 84. The good news is we don't have to find g prime of x. Remember our formula that we just figured out? We know that based on our formula, g prime of x has to equal 1 over f prime of g of x. Right? We just figured that out. Let's apply this formula. So this means that g of 84 has to equal 1 over f prime of g of 84. Right? I'm just applying this formula. So all I'm doing is I'm erasing the x and replacing it with 84. Okay. What is g of 84? Well, remember, f and g are inverses. If f of 4 is 84, that means g of 84 is 4. Because if f takes us from x to y, gx takes us from y to x. Let me say this more clearly. If f is a function that takes us from x to y, g is a function that takes us from y to x. It's just the opposite direction. Therefore, g of 84 must equal 4. Since g of 84 equals 4, I can replace g of 84 with 4. So the derivative of so g prime of 84 is just 1 over f prime of 4. Okay. All right. What is the derivative of f of x at 4? F prime of 4. Well, if f of x is 3x squared plus 6x plus 12, then f prime of x is 6x plus 6. So f prime of 4. So f prime of 4 has to equal 6 times 4, which is 24, plus 6, 30. Okay. In other words, f prime of 4 equals 30. So I can replace f prime of 4 with 30. Okay. And that gets us there. So g prime of 84, which is what we're looking for, must be equal to 1 over 30. So we can find the g prime of 84 without figure out what g prime of x is, because that's going to take a lot longer. Trying to find the inverse of f and then derivative. Okay. Example 2. This time, we're given a table. We're given a table of x, a of x, b of x, and a prime of x at x equals 3 and x equals 5. We're told that a and b are inverse functions, and we want to find b prime of 3. So again, what do we know? We know that a of 3 equals 4. That's what that says, basically. This is saying a of 3 equals 4. And what does this say? This one just tells us that a of 5 equals 3. Similarly, based on this table, b of 3 equals 5, and b of 5 equals 6. And then finally, a prime of 3 equals 3, and a prime of 5 equals 2. That's what this table tells us. Okay. So we want to find b prime of 3. Well, we don't have b prime in our table, so we have to use our formula. We know that alright, so let's apply our formula. So we know that b prime of 3, well, actually, let's start from the beginning with our formula, and let's use a more colorful, bright color. So b prime of x is 1 over a prime of bx. We know that. That's just the derivative of inverses, since a and b are inverse functions. We want b prime of 3. We want b prime of 3. So, okay, let me sign back in. Okay, signed back in, sorry. So, we want b prime of 3, so x equals to 3. So I erase this and write 3. Okay, well, let's look at the first term. What is b of 3? We see from here b of x, when x is 3, b of x is 5. So again, this term tells us that b of 3 equals 5. Okay. Therefore, I can just replace b of 3 with 5. I accidentally erased the opening parentheses, so right here. In other words, b prime of 3 is 1 over a prime of 5. Next up, we want a prime of 5. That we look here in the table, a prime, and we want x equals 5. So a prime of 5 equals 2. So I can erase a prime of 5 and replace that with 2. Therefore, b prime of 3 must be equal to 1/2. Okay. So what did we learn? We learned that given inverse functions, the derivative, whoops, the derivative of a is 1 over the derivative of b of a of x if a and b are inverse functions. Why is this useful? Well, it's useful because we can find, say, a of 5 without knowing what a prime of x is, as long as we can figure out b prime of a of 5. So if we know a of 5, and let's say a of 5 is 3, and then we know b prime of 3, we can figure out a prime of 5 without calculating the derivative of a prime of x. Okay. All right, that's it for this video.